Hello everyone. In this video, I will teach you how to create your own patches that you can submit to the official kernel maintainers, to the mainline kernel tree. So I'll tell you the development process involved with a small demonstration to tell you the flow that's involved. So what we'll be doing is we had created a file that is a program that exposes the jiffys variable via /proc in the earlier video, right? So we had created that in the session where you can see, okay, 1 minute. Let me just go to the actual window where I have that. Yes. So we had this file called /proc, we had this file called procjiffys.c. And this particular file, when you compile this as a module, when you build this as a module and you load this, this would expose a file called /procjiffys, or a folder in which there's a file. Let us say this is a useful feature and you find it compelling enough that this should be a part of the main kernel, and you want to submit this as a patch to the official kernel maintainers. What is the process involved? How do you go about doing it? We will learn that. To begin, you need to sync up with the Git repository of the mainline kernel tree. So I'll just go to the terminal where I've done that. So here is a folder where I have synced with the Git repository of the mainline kernel tree. To be sure, I'm going to do a Git pull to synchronize any upstream changes that have occurred. Looks like it is properly synchronized. I did this just a while ago. And now this mainline kernel that is there, I want to include this code that I've written into this kernel source tree and then create a patch out of it, which I can distribute it to others or maybe submit it to the mainline kernel. So because I'm adding a new entry in the /proc, it makes logical sense to include that under fs/proc folder alongside with version.c and maybe cmdline.c and other files. I want to have that procjiffys.c in this folder. Let's do that first. To begin, first of all, I should show you that the Git the Git repository here is in the master branch. As you can see, it's on branch master. The good practice is to create your own branch so that you don't clutter the master branch. Otherwise, you have to go back and forth in commits. Some people do that. But I suggest creating a new branch for any changes that you make, that you can work on your own branch and then create a patch set that you can apply to the master branch, right? You can do that. So I'll just do a git checkout -b. -b is to create a new branch. Let's call this as proc jiffys patch. So this is a new branch I'm creating. When I do a git branch, you can see that I'm currently pointing to the proc jiffys patch. So I'm that branch. In fact, my command prompt, where I'm using Starship, shows that I'm in proc jiffys patch anyway here. So if we do a git status, as usual, it is exactly similar to the master branch. It's just forked off from the master branch. So I can make any changes in this branch without affecting the master. I can go back to the master branch and drop this branch if I'm not liking it, right? So here, I'll just copy this sources. It's there in /root/ it's called Linux Kernel Intro /samples /07 loadable kernel module /proc jiffys. Under this folder, I'm interested only with the source file, single file. So I'll just use procjiffys.c. I'm going to copy it here in fs/proc. The fs/proc folder, I just added my file. I'm integrating this in the kernel source tree, as you can see here. Now, after I include this file in this location, I want to make sure that when you build this kernel, it has to build even my module as a part of it, right? So to make that happen, there are two files I need to modify in this case. One of them is the kconfig file. Another one is the make file. The kconfig file I'm going to create a new config macro. I'll go ahead and do it now. So it'll be more convenient to just copy an existing entry. Then later on, I will tell you the syntax grammar for kconfig. How do you learn about that, right? So I'll just go to vi fs/proc/kconfig, edit the kconfig file under that folder. You can see this has a particular format and particular syntax. Kconfig is its own macro language used by the kbuild system. And there are a lot of config macros that you see here. So it's a config macro where you can decide what should be the config name. this will end up creating config underscore proc underscore fs. When you say config proc fs, and this will show up in the make menu config and make end config in the make config target, whereby the user can choose an option whether to enable or disable it, right? So here under proc fs, what I'm going to do now is I can see one config macro here, config proc kcore. I'm just going to copy this entire block, and I'll paste it on top. I'll change this proc kcore to proc GPs. Instead of making it a boolean, I'm going to change it to a try-state checkbox. The bool macro here will show up as boolean, show up a checkbox where you can enable or disable. But by changing this to something called try-state, you'll end up having an angular bracket as a checkbox where you can enable it into the kernel. You know, when we did a kernel build, kernel compilation in the earlier videos, I showed you a lot of options in which you'll see some of them are angular bracket checkboxes or try-state checkboxes where you have three options. One, you can say yes to build this component into the kernel that is statically linked into the kernel, or build it as a loadable kernel module, or do not build it. Three options: yes, no, or M, right? To get something like that, I use try-state here, and I'll just say /proc/ Jiffy support. Sorry. Jiffy support. This existing Kcore config depends on specific platform. I think it does not work on ARM. That's why they put a if not ARM here. So I'm just going to remove this clause. And this only depends on procfs support. So I'm just going to use depends on procfs. My configuration or my module does not require enabling of any other configuration. So the select option I'm removing, and help, I can just write my own detailed help here. So where I'm just going to say expose Jiffy's variable as /proc/ Jiffy's. This might be useful for Jiffy's based timing instrumentation. And diagnostics. In the user space. I just put some arbitrary message as help. You can put anything, right? So if you have your own driver, your own device driver, this is the same process you'll follow. You will include your driver code base in the kernel source tree in the appropriate folder. Because I'm adding an entry in the /proc, I put it in fs/proc folder. But if you're writing your own device driver, it should go to the drivers folder in that hierarchy. You may go, if it's a networking driver, it should go in driver/net or likewise, right? So once you include your code in that folder, you have to modify the kconfig to also show up configuration macro for enabling or disabling, or maybe build it as a module that is your driver. And this is the template that you follow, right? And then after that, note down the config macro I've used here, config proc_jiffys, a unique name for this particular configuration, which we are going to use in the makefile next. So modified fs/proc/kconfig. The next file I need to modify is the makefile under fs/proc itself. And in this makefile, as you can see, there are a lot of rules here. Build this object, which one? proc.o. That will be statically linked into the kernel when you say obj-y. And this proc is made up of various other components, which are all statically included as a part of building the proc file system support. There's something over here. You can see this proc-$config tty plus equal to config. I can see proc tty.o. Likewise, I'm going to add a new line here. I just open up a new line. I'll type proc-config_proc_jiffys. When in the kconfig file, I said config space proc GPs. That configuration based on the user selection when compiling the kernel will end up creating a macro called config proc GPs. If that macro value is substituted here, this will be translated as proc-y or proc-m or proc-nothing. If it's proc-nothing, ignore that .o file, that will not be built. Proc-y means build created as a built-in module, statically linked into the kernel. Proc-m means build it as a loadable kernel module. That's what I'm going to do here. So it's a plus equal to, that is proc underscore gps.o. So added this line too in the make file. So I did three things. I copied the proc gps source code in the fs/proc folder. Then I also modified the kconfig file to add my own configuration rule, and also modified the make file to also build my sources based on the configuration setting. Now this kconfig file, whatever you added there, will show up in the make menu config or make nconfig target for building the kernel. So if at all I want to demonstrate this, I can just do a make. I'll use O is equal to, capital O is equal to /temp, a temp folder, and maybe menu config. So this is a make menu config target, right? You get a menu based configuration. You can also use make nconfig, which is pretty recent, and if you're comfortable using it, right? It's all the same. So the make menu config, if you go to the file systems, your entry for /proc should show up in here under sudo file systems. If it's not shown here, what it means is that you need to enable expert level settings, and you do that in general setup. Yeah, some of these configuration options are visible based on enabling some other options, right? They have the rules. So I'll go back here. I'll go to the main, in the main section. I'll go to general setup. In under general setup here, you scroll all the way down. I guess a little more up. Okay, where is it? I missed it somewhere. One moment. I'm sort of blinded by so many entries that comes up here. So it is somewhere around here. Just one moment. Let me just show you. Profiling. Kernel configuration, kernel level. There's something called expert level settings, which should be there somewhere around here. I'm in general setup, right? Okay. Yes, I am. Auditing support, IRQ subsystem, BPF, RCU subsystem, kernel.config support, scheduler features, boot config support. Yeah. Actually, it's called configure standard kernel features expert users. Sorry, I missed that. I was looking for a word called expert in the beginning. It's there somewhere around here, right? This is the configuration that you look for. In fact, the macro for that is config_expert. This must be set. Only if this is set, entries for proc file system will show up in the make menu config, right? That's what you should know. So let me enable this. Just turn this on. Come out and go back to file systems this time. Sorry, I meant to device drivers. Go to file systems. Under file systems, select sudo file systems. Under sudo file system, you can see that /proc file system support. You can turn this off. I have no idea why somebody will turn this off. Maybe a lot of user land tools will not work. Top, free, mount, none of these commands will work, right? If you actually disable this. So keep this on. You can see that just because I added a config macro in the kconfig file, which is config proc_gps, and then tri-state, I said proc gp support, right? You can see an entry coming up here. It's a tri-state checkbox. It also shows new. That means it was not there in the existing configuration in my running kernel. It's a new feature. So if at all I want to turn this on, I can say Y here. This will statically link into the kernel. Let me show you what happens when I save this. When I save this, I'll go back to another terminal. And look up in /temp/.config, because that's the output directory that I chose when I did a make, right? I said make O is equal to /temp for testing purposes. So in here, the config file is generated, the .config file is generated, which will be used by the kernel build system to build this kernel. If I try to do a make or make tar xzpkg or any of those rules, right? So in here, let me search for proc gfs. You see this? Config proc gfs is equal to y. So therefore, in the subsequent make file that I had modified, I put a proc $$ of config proc gfs plus equal to, right, proc gfs.o. That'll get translated as proc -y. That means it will be statically linked into the kernel when you do a build of this kernel now, right? It'll become a built-in module. But then if at all I choose to do it differently, where if at all I say build it as a loadable kernel module by pressing M here, I can also use spacebar to toggle this. As you can see, I'm using spacebar to toggle this, but I'm selecting the option as M. That is build it as a module. You can see on top, right? M/proc gf support, and try to save this. And if I just go back and check, I'll do a grep here. Grep config proc gfs in /temp/.config. You can see that it shows up as config proc gfs is equal to M. That means it'll translate to proc -m in the make file, which will build it as a loadable kernel module, not statically linked into the kernel as a part of proc subsystem. So you have to use modprobe to load it in from userland. So this is what happened. If at all I don't want to build it at all, you can also choose that by just selecting no here. If I save this now to the .config file, you go back, you can see this. It's just commented out. That means this particular feature will not be built. That means proc.gfs.o will not be generated, and it will not be compiled to a .ko file, or it will not even be statically linked into the kernel image. So this is how you can use make menu config, and the make menu config reads this information from the kconfig rules that we just added by copying an existing one. But to understand what are the different rules you can use in kconfig, which is a vast topic on its own regard, I just quickly showed you how to adapt by using an existing kconfig rule and just make some subtle changes to make things work, right? So if at all you want to learn more about the kconfig rules in general, in the kernel sources, if you go to documentation, under documentation, there's a folder called kbuild. Under kbuild folder, there are a lot of documents in here in which you can see a file called kconfig language.rst. You want to start from there. The configuration database is a collection of configuration options organized in a tree structure. It tells you about the menu entries, how the menu entries look like, config and config name. Then it could be what kind of menu it is, whether it's a Boolean, and does this menu depend on some other configuration to be enabled? Does it select any other configuration, and what does it help? These are the standard formats that you'll find. The menu attributes, you can use Boolean, you can use input prompt, you can use what is the default value you can set for it, and you can see this. There are a lot of options. Dependencies, depends on what. So all these rules are shown here with examples. It's pretty detailed. It's a detailed document. Wow, it's big, right? It's a detailed document. Not just that, you also have kconfig macro language, which will give you the syntax grammar for the kconfig macro language itself. It tells you how the macro language works and what is the syntax grammar for it, how do you define variables and all that. The complete rule is provided in here, right? So this is where you can learn about the kconfig syntax by looking at kconfig language and kconfig macro language. To know more about the kbuild, you can also look up kbuild.rst. This will tell you the roles of various files when you use kbuild. What is the role of modules.order? What is the role of modules.built-in, modules.built-in modinfo, and a couple of macros that are used. The kbuild, right? It shows up. Shows it. You can see install mod path and install mod dir, install mod strip. See many of these macros. Most of these could be used in the make files or kbuild files, right? You can see them. So all the kbuild rules are also shown here. So this folder gives you all the details that you need to know about the build process. See, let me tell you that because I'm adding a new feature into the kernel, I need to meddle with makefile and kconfig rule. But many times you identified a bug in the kernel. You looked at the source code and you realize a silly bug in it, and you want to just fix that bug. For fixing an existing bug in the source code, I don't think you'll need to worry about kconfig or makefile rules because you have just modified an existing C sources. There, you don't have to worry about these things. You just modify the existing C source in your own branch, and then after that, we can get a patch set. So far, let's assume that I build the kernel. I'm not going to build the kernel at this moment because it's a long process. It'll take more time to build the kernel. So you can try it out. Try building this kernel, right? Make it a built-in module, build the kernel, boot. During boot, you should see that the proc GPs would be initialized and it'll be available by default when you boot the kernel, but you can also build it as a module. In such case, a module will be part of the kernel source tree, will be installed in the lib modules kernel folder tree itself, and you should be able to use modprobe and load it when you need it. So all these tests you can do. Once you tested it, if it's a real device driver that you're writing, same process. You build the kernel with all these integrations and changes you made, and then you test your driver thoroughly, make sure your driver works and works perfectly fine. And after that's done, now it's ready for submission to the mainline kernel tree inclusion. To do that, this is what you do. Sorry. I'm going to come out of this. Let's assume that everything looks good. Everything is working well. Do a git status. You can see that these are the files. One file is being added, two files being modified. Let's stage them by using git add dot. And now you do a git commit. Don't use a -m switch here. Very important. Just do a git commit. Whatever editor you configure as default, that editor is used. In my case, I'm using the Vim editor. Some of you might use Emacs or nvim or this NeoVim, that is. So you can use any choice of editors that will be opened up. Because I'm using Vim, it provides some interesting syntax highlighting here. So here the first line is supposed to be the subject line. So I'm going to type a one-line message, which will act like a subject to an email, right? So I'll just say expose GPs variable via /proc/GPs. Note that the first line should not exceed 50 characters. Just see what happens when I keep typing. See the color changes. This indicates that I've exceeded 50 characters. You can see this. The moment it goes to 51st character, the color changes. It's a hint. So make sure that whatever you type in the first line is a subject line. Leave it to less than 50 characters. A very simple description on what you're doing. And then don't write in the second line. You see the highlight here? This means you're not supposed to write to this line. So leave this line blank. Open up a new line. This is where you can provide your own custom description. It has nothing to describe. You can leave it blank. But if you have something to add, more detailed description, maybe you can add this here. So let me just write some template description, which is not a good practice, but I'm just going to show you what you can write here. So you can just say dispatch adds support for exposing defease variable via /proc/defease, which can be useful sometimes in user space instrumentation and diagnostics. any description. Most cases, if you're fixing a bug, if your patch is about fixing a bug, you might also include some hint on what is that bug and what is the kind of crash you encountered. And that's useful, right? So any kernel maintainer will know, oh, okay, that bug, that's really a bug. Maybe some concurrency issues or some race conditions or something like that. Or if it's a buffer overflow possibility or memory leak, these kind of bugs. What kind of bugs you detected, and that's what you'll put up in this description. That's it. So once you're done, commit this. Once it's committed, now the next step is to create a patch out of this. If all you want to create a patch file separately, all you can do now is using git command. You can just use git format patch. And right now I'm in the proc jiffies branch, which is a fork from the master branch. And that's where I made all the changes. I made one commit. Now that commit is different than the master, right? The master commit. So the git format patch will give you a patch based on the difference between the proc jiffies patch to the master. So that's what it does. So you say git format patch and you say -o, very important, -o /root any location, maybe /root/ I can just give a folder. I'll just do one thing. I'll just create a folder called /root/patches, for example, a dummy folder. And I'll repeat this command. Git format patch -o /root/patches. That's a folder. And master. So it'll create a patch based on the differences of the master to your branch. Remember, if you have made multiple commits, it'll create multiple patches. You'll have patch 001, 002, 003, multiple patches. So you can have a patch set like that. So because I made a single commit, I get a single patch, and this is what it looks like. Yep. You can see that. /root/patches /001 expose jiffies variable via /proc/jiffies.patch. That's the subject line. Now, if you look at this file, this looks like a typical email message, doesn't it? So you can see a from address here. I think I configured my Git username as Linux hacker here on my Git configuration. Change that. Okay. If you're using your Git, just use git config and change your username and user email to a valid email address, right? Which others can, contact. And then you can see the date. And again, you can see the subject. It shows patch expose jiffies variable via /process jiffies. And this is the actual email body. This is the envelope headers for the email. This is the email body. And after this triple hyphen, you can see the actual patch that shows up here. If you closely observe, this is no different than the emails that you'd see in the LKML mailing list. Am I right? So if you go to the LKML mailing list, that is the Linux kernel mailing list. You can go to kernel.org and you can also click on this kernel mailing list here. There's so many mailing lists being listed here. All of these are different mailing lists. The Linux kernel mailing list, LKML, right? You just go to this place. So you can see this. A lot of these mails have come up. You can see a patch here. See? Current mail, right? Patch 2024, right now, I think today. Platform x86, ASUS WMI, don't fail if platform profile already registered. This was the subject. I click on this and you can see the actual mail message. You see this? Somebody's actually replied to this, looks like. Oh, it's a complete thread. Sorry. Yeah. This was a patch. See? Patch platform, ASUS WMI, don't fail if blah, blah, blah. The subject. And this was a description that the author has written, which was actually as a part of git commit, right? And after the patch was created by using git format patch, this is what happened. Generally, if it is looked up by a maintainer, the maintainer will also sign off the patch by using git sign and get a signed off message also. So that telling the upstream maintainer that I have verified this patch, it worked on my machine, I've integrated into my tree, looks good. So that's how the trust is being built. And this is how the patch looks like. And yes, if you go to the lkml.org, you can also see the archives what's going on. So all these patches are submitted pretty much the same way, right? Pretty much the same way. This is how patches are submitted. So you can use git format patch, and then you can use this in your email client. Don't use email clients like Microsoft Outlook or some of these exotic email clients that use HTMLized email. They will not like it. Use an email client that sends plain text, not HTML. And patches are supposed to be sent as email, not as attachments, not as email attachments. Things to keep in mind. So this must be your mail body, the envelope header and the email body, right? Some of you might now wonder, what if my patches got like 5,000 lines? Bad idea. Such cases, you won't send a mail like that. In such cases, it's just that if it's a very big subsystem that you wrote separately, you can put it up on your own Git repository, create your own Git repository, and maybe send a message to LKML that you did this subsystem on your own and this code is very big, and you can, if people are interested, can do a Git pull from your repository. If it's really interesting, some people might look into it. In most cases, the suggestion is they don't like you to submit a big patch of 5,000, 10,000 lines of code or in megabytes. No. If you plan to contribute to the kernel, you want to start early, providing trickles of small patches as you go along. As you develop, you submit patches as early as you can. Release early, release often. That's the mantra. That is the cycle that you follow. So that people can, do early reviews when they look at a small piece of code, people can contribute easily. So you think about the mindset. You don't want to be selfishly working on some code. What you should do is you want to give up the code as early as you can to get contribution from the community. So if somebody is interested in whatever patch you submitted, maybe to a new driver, the other kernel developer might also be interested in adding some features. And it's easy to add feature to a code base that is smaller than a code base that's very large. It's also very difficult to review them to check whether it breaks the kernel. That's the reason why people generally in the kernel community will steer clear of large patches that people have worked on for maybe several months or years, and they come back as a surprise and show them. They'll ask you to leave it in your Git repository, and when people find time and they find interest, they will try to trickle down your patches into the mainline kernel tree through Linux Next project. So always keep that in mind. There are very rare scenarios where your driver could be running about 100, 200 lines long. It's fine. You can submit it as a patch. But if it goes to very large sizes, obnoxiously running to megabyte size, that's a red flag. You shouldn't be submitting patches like that way. You can put it up on your own Git repository and send a request in the kernel community that you have your patch available there that solves the so-and-so problem. People who are interested will trickle down patches into the mainline kernel tree after reviewing and verifying them. The maintainers mostly, right? So you can see the entire patch is available here. Now you can also use another command. The command I used to create this patch is what? I used this command. Very simple. Git format patch -o to create this file. If you use a command line email client like Mutt, Alpine, or any of these tools like, send mail or anything, send email or so on, these tools might understand this mbox format file, and you can use that to send it as email, right? So, but then if at all you want to send email through Git, assuming you configured your email server properly, and you have an email server or an mail transfer agent configured in your Linux system to send emails, you can send it. If at all you want to send, if you don't want to do that and you want to use a graphical user interface to send email, you can use Mozilla Thunderbird or any such email clients. There are many email clients available on Linux, Evolution, Mozilla Thunderbird, and all of them. You can use them. Make sure you don't enable HTML email. Send the email as plain text following the etiquettes, right? And here, if you want to send email via Git itself, you can also use git send email. The send email command will take the same option. You can say get send email, and you can say -2 is equal to the maintainer for that code. Now, who to send it to? Well, do you want to send it to Linux towards? No, not really. If you're actually contributing to some subsystem of the kernel, find out the separate mailing list or the mail ID for the subsystem maintainers and send it to them. The way you find that out is you can also use the command. It's a helper script that is there. You can do a in the kernel source folder, you can use scripts slash get maintainer.pl and put a -f and then use fs slash proc. Because you're modifying some files in slash proc, see who owns kconfig or makefile. Actually, this is just a glorified script on top of git blame command. It calls git blame. You'll also see my name coming up there. That is Linux hacker, right? Look up kconfig or the makefile. So you can see a lot of individual maintainers who have contributed different code parts, including my email ID, dummy email ID, which I have here, right? But from this, you should make up your own mind and find out the main contributor. You can see there's a dedicated mailing list, Linux kernel at vigor.kernel.org. This is where you should be submitting. So you can see it's an open list, right? You can also see Linux FS Devil. Maybe you can send it to either of these mail IDs, or maybe send it to one of them and CC to the other. Perfectly fine. So to do that, you can actually use git send email --2 equals Linux-kernel. Oh, don't worry, this will not go to the kernel mailing list. I've not configured the mail transfer agent, by the way, right? And yes, don't do it for Hello World kind of programs. It will be very, very annoying to the kernel maintainers. You might get blacklisted from the LKML mailing list. So don't toy around, right? So you can experiment on your own system. But if it's time to submit as a mail, that means you're like going as a frontline warrior. You better be prepared, right? So make sure you do all your checks and sanity checks and everything. And then when you really know that is really useful to others, then you follow this rule. So vigor.kernel.org. You can also use --cc is equal to and specify another email ID and so on. And then ultimately, all you need to do is just do, master. That's it. So this, instead of creating a patch file and storing it on your disk, you'll send it as email, assuming you've configured a mail transfer agent or a mail server properly on your Linux system, which I have not done in this virtual machine, obviously. But I'll tell you some of the options that git send email has. I just type the command. It's not going to work. Yeah, it's asking, send this email, yes, no, quit, all. It shows all this stuff, right? Above is being expanded by additional addresses found in the patch commit message, blah, 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 blah. It tells you all these things. It also asks you sort of things. If you say yes, it's going to send us email. I'm not going to do that now. I'll tell you what all things git send email understands. You can do a git help send email. We'll show you all the options that are available. All these are the composing options. You can use CC is equal to, BCC is equal to. What text editor do you want to use to compose the email if you want to do some final touches, right? For editing the email. What from address you want to use. If you don't want to use the from address that you get in the commit address, right? The commit, you want to use your local mail ID. But when you submit it as an email, you want to put a mail ID that can be reachable from the public. You can specify the different from address, reply to address, and all this. And if you're submitting a reply to a patch in reply to another patch, you can say in reply to and a reply identifier. I can pass that. Subject string can be changed to address. This is what is important. And all these options are provided here. These are compose options. For configuring sending of email, you can also specify the send mail command. Or if you want to use an SMTP server, all the SMTP related credentials like domain, authentication, password, all of these stuff can be used. Server and port, all this can be passed on. So this will submit this patch as email to the kernel developers. And this is how patches are created and submitted. Maybe you don't want to send it to kernel developer, you want to send it to your friend or colleague, so that whatever changes you made to the kernel, you want to send it to your team, so that they can inculcate them into their code base. Same process. So this is one rule. Now, let's assume that I am the maintainer and I got a patch by email. Assuming I'm having a proper email client that uses mbox format files, where every email is stored as a separate file under my home directory / inbox or mbox folder or mail layer folder, I can take that file and apply them. So let's say I want to work as a maintainer, taking in patches by email, which I got it, or maybe the patch file is given to me and I want to apply the patch. How do I do that? It's pretty straightforward. I'll show you how it is done. This time, I'm going to switch to the master branch, git checkout, master. And as you can see that I'm in the master branch right now. And if you also verify /fs/proc, you won't find a file called proc.gfees.c. The proc.gfees.c is not there. You can see that right here. There's procnet, proc.sysctl, but there's no proc.gfees, right? So this a clean master branch that is there. In order to test a patch, what I could do is I could actually do a git checkout -b, create a separate branch. I don't want to clutter the master branch. So I'll create a separate branch which I can then delete it off easily later on, right? I'll create a separate branch. I'll just call it as test patch. Now it automatically switches to the branch, of course. We do a git branch now. It forks off from the master branch, creating test patch branch here. So if you just see again fs/proc, you can see that proc.gfees.c is not there. The kconfig and make files are not modified. You can do a git status to even verify that. It's a clean fork from the master branch. Now on this, to apply the patch, all I do is git apply. That's it. Git apply /root/patches. I maintain the patch there, right? Provide the patch file name. That's it. You will get some warnings sometimes if proper coding conventions are not followed. Looks like there are some trailing white spaces here. Yeah, there are some trailing white spaces around here. This figures it out by running a tool called lindent, which is found in the scripts folder. So it throws these warnings, but this is because I'm not followed, because the developer is giving me the patch as myself. I have not followed the proper coding guidelines. Maybe some trailing white spaces are there in a couple of these lines. That must be fixed. But once everything looks good, you can test it, look up the patch, test it, and then if all looks good, then I can sign off this patch and submit it upstream. That's what I do here. So to check it here, I can just do a git status this time. It shows 2 files being modified and 1 file being added. And you can also verify that you do fs/proc. As you can see, there's a file called proc.gfees.c appearing in the system, in this kernel source tree. I can do my own test if I want to. I can review the patch and make sure that my build does not break all those things I test as a maintainer. And then if things looks good, I can submit it upstream to the upstream maintainers, right? This is a process that you'd follow for creating a patch and submitting it to the kernel development, community, right? So all this concept I covered is very nicely documented in the kernel source tree under documentation, under a folder called process. There are many files in here, but some files that I recommend you to read. Of course, the first files, like you can see here, intro, RST, process, then early stage, coding, posting, following through. Read all of these numbered files to make sure that you are working with the community, staying in tune with the actual development process, which can change over time. Then they also tell you about adding new system calls. If you're adding a new system call, read this. There are good reasons why you should not add a new system call on Linux. That particular document covers it. How do you apply patches? How do you do backporting from the main line to the stable trees, and watching up ioctls? It's a nice document. The do's and don'ts when you're implementing ioctls are covered in here. Code of conduct. If you're writing mails, the etiquettes are shown here. You can also look at mail clients. What are the mail clients to use, and what you should not use, and how you should be sending mail. And the code of conduct talks about the coding information and coding style guidelines. The coding style guideline you should follow for writing your code. Generally, Linus Torvald will hate code that does not look like the code he is comfortable with. So you have to follow the coding guidelines to make sure that your patches don't look very off from the others, right? So follow that. And there are also other things like you can see, look at submit checklist, submitting patches. And there's also other features like To know as a maintainer, what are the things you should keep in mind as a maintainer? That is covered in here: management style, maintainer tip, and so on. So look through these documents. There are a lot of documents in here, right? And all of these documents are also available if you want to look it up from a web browser. As usual, you can go to the kernel documentation, go to kernel.org, and under kernel.org, select documentation in the browser. And once you go to documentation, you can see over here there's something called development process. Go through this. Talks about the kernel development process and all the other things, submitting patches. How do you submit a patch? So whatever I covered here is documented in this documentation for it to read through. There are more details provided which I could not cover in this video. Of course, I want to keep the video not too long. It's already a long video of going beyond an hour, beyond 1 hour, but I just covered in a very crisp manner what are the important things to keep in mind and showed you what it takes to create a patch or what it takes to apply a patch. But all the details and nuances and things to follow, read through his documentation. Okay, and they are updated over time. They tell you about a couple of things: no mime, no links, no compression, no attachments, just plain text, as I mentioned that, right? All these are covered in here. It's quite detailed. This pretty much covers the topics for Linux kernel development. So we learned right from the very basics about what Linux is, and we also learned about more about the Linux kernel features. We learned a bit of history, about interesting operating system concepts, and we learned how to build the kernel, how to custom compile a kernel with our own custom configuration. We also learned how to create kernel modules and what are the things to keep in mind when you're writing kernel modules, important bits of it. We also learned how to interface with proc file system, debug file system, and how do you submit a patch to the kernel community. This concludes the introduction to Linux kernel development training course. There are forthcoming training courses which I'll be talking about in the concluding video. So if you have any further questions or doubts to this particular topic, feel free to reach out to me. Thank you very much. So meet you in the next one. Meet you in the last video after this. Thank you.